Hey, welcome back. In this video, we will solve the valid palindrome problem on LeetCode. Okay, so before moving forward, let's see the problem description. So here it has given the palindrome description. So a phrase is a palindrome if after converting all uppercase letters to lowercase letters and removing all non-alphanumeric characters, it reads the same forward and backward. Okay, so alphanumeric characters include letters and numbers. Okay, given a string S, return true if it is a palindrome or false otherwise. Okay, so here is our input here. Okay, so this is our input and this is our output, which is true. Okay, why is that? Because after removing all of the alphanumeric characters and converting it to basically lowercase, all of the characters to lowercase, it works the same. Basically, it reads the same in forward and backwards. Here we have the example 2. It is basically saying like it is not a palindrome, and then we are having the empty string, which is true. So for empty string, it should be true. And here after this constraint here, so constraint is this one, which is good. And here we are having a small hint about how we can solve this problem. So the S consists of only printable ASCII characters. So what exactly the printable ASCII characters? Here it is. So I have just Google searched here. Okay, so ASCII printable characters here. All right. And as you can see, there are a bunch of things, and all of the printable characters have the ASCII value associated with them. Okay, for example, for 0 it is 48, and so on and so forth. All right, so now let's go to the Excalibur and let's solve the problem. So for example, here we are having A, B, then colon, C, D, C, and then let's do B and A. So this is a palindrome here. Okay, so why is that? Because if we convert this one, so A, B, C, D, C, B, A. Okay, so it just goes here. So in the forward, it is something like this, and in the backward, it is the same. Okay, so now how we can solve this problem? So we can solve this problem in the brute force approach. Okay, so what we can do, we can have a new string here, which will be empty string at first. All right, and then for each of the characters here, for each of the characters in the S, basically this is the S string which we are given. So ch in S, basically what we can do, check if the character is alphanumeric. Okay, to check inside of Python if a character is alphanumeric, we have the is_alnum function. Okay, so we can use that here. And then after that, what we can do, we can just do something like this. After it is done, then we can reverse the new string. Okay, because the new string is stripped down basically. And also what we can do, if the character is alphanumeric, then we can just lowercase, so ch dot lower, we can just lowercase it and push it up. So new string, okay, it is a little bit cluttered here, so I will just get rid of this one. So new string dot push. Okay, let me just do something like this. Push, what we can push? The ch dot lower. Okay, so we will create all of the characters in lowercase and push it up inside of the new string. So in our example, the new string will look something like this. So for the S string, the new string should look something like this. Okay, and then what we will do, we will just reverse the new string and then check if the new string reversed version is equals to the new string. Okay, if that is the case, then it is palindrome. If that is not, then it is not palindrome. Okay, all right. Now, as you can see, this is our whole algorithm here, but there are some of the problems here. Why is that? Because first of all, we are having this empty string here, and we are basically manipulating the string. And in most of the programming languages, strings are immutable. That is why for this particular one, you might think the time complexity of this particular algorithm can be O of n. But in reality, the time complexity will be big O of n square. Okay, because we are manipulating the string. So when we are manipulating a string, basically we are creating a new string in place. Okay, time complexity, that is basically big O of n square. All right, so what exactly is the space complexity? The space complexity will be big O of n. Okay, why is that? Because we are creating a new string here, right? That is why the space complexity will be big O of n. So now the thing is, can we do better? Yes, we can do better, and we can do better by using the pointers. Okay, so what we can do, we will go here. Okay, and once again, let's create the S string here. So A, then capital B, colon, C, D, C, B, A. Okay, all right. So this is our string. So now here we are having the input string here. So what we can do, we can create two pointers here, one at the start and one at the end. So if that is a palindrome, then the lowercase version of both of the characters should be same, right? So if that is the same, then what we can do here. Okay, so first of all, what we need to do, we have to check if the character at the left pointer, if that is not equals to character at the right. Okay, if that is the case, then it is not a palindrome, right? At the same time, all right. So this is one of our check. Then we can just return false. All right. So this is one of the checks. Then what we have to check here, if this is not an alphanumeric character. Okay. So here what we can do, we have to check if, first of all, the left pointer, okay, the left pointer is basically less than the right, and not is L_num of the character, okay, at the left. Okay, if that is the case, if it is not the alphanumeric character, what we can do here, we can move our pointer currently right now. Okay, so then what we can do, we can do left, then plus equals to 1. So we can move it out here. And also we have to check if the right is basically greater than the left, and once again, not what is L_num ch at the right. Okay, this is basically the pseudocode here. Okay, so don't worry about the things, we will write it down in a much more cleaner way when we will be writing our code. If that is the case, then what we have to do, we have to do right. Okay, this is not right? Then minus equals to 1. So we have to change it up here. If we are able to find a match, okay, if we are able to find a match, then what we have to do? We have to do the same thing, basically left minus equals to or plus equals to 1 and right minus equals to 1. Okay, so I hope that makes sense. Now let's see that in action. First of all, we will check if this character, which is this one, the A one. So let me just do, okay, the laser pointer here. So this is the one. So if this character is equals to this character in the lowercase version, yes, it is. Then what we can do, we can move our pointer here. Okay, so let's move our pointer. So this pointer will be going to here and this pointer will go to here. All right, awesome. Then we will check if the lowercase version of this character, okay, if the lowercase version of this character is equals to the lowercase version of this character, yes, it is. And also these are not like these are alphanumeric values, right? These are not some special characters. Okay, so we are able to find once again a match. Then what we have to do, once again, we have to move our pointers to here and we have to move our pointers to here. All right, now here, as you can see, this colon is not a alphanumeric value, right? This colon is not the alphanumeric value. Then here, as you can see, if I just go down a little bit, we have written down this one. So if the left is less than right, yes, the left is currently less than right, right? All right. And the character at the left, is not an alphanumeric value, right? So that is why we will not do anything. So we have to change our left pointer here, only the left pointer. Okay, so now what we'll do, we will just move the pointer here. And now once again we will check if this character at the C, basically here, this character lowercase and this character lowercase is basically the same. Yes, it is. So that is why what we will do, we will move our pointer here. So let's move the pointer to here and let's move this pointer to here as well. All right, so now we are having at this character basically only one character here, and then basically what will happen, our algorithm stops. Okay, so as you can see, the two pointers are at the same character here. We will check if those are the same. Yes, it is the same. And then we will return true. Basically, we are able to traverse through all of that because after this point, this left pointer will be at the right side of the right pointer. So which we do not want. Okay, I hope that makes sense. So this is our algorithm. And once again, here, what exactly is the time complexity? So let me just do something like this and let me just go here. So time complexity will be big O of n. Why is that? Because we are traversing the string only one time. So what exactly is the space complexity? That is basically big O of 1. Okay, because we are not allocating any other space, right? So this is our algorithm which is optimized here. Okay, and also one thing to point out here, for the ASCII printable characters inside of Python, here we are having the ORD function. If we pass any basically character, so a something like that, we will get the ASCII value. Okay, so we do not have to memorize all of these tables inside of this ASCII table, right? All right, so we have understood how we are gonna solve this problem. So now let's code it up right now. All right, so now let's see the naive approach. So let's do new string equals to the empty string here, and for character in S, what we can do if the character dot is lnum. So this is a inbuilt function in Python. Okay, if character is alphanumeric, then new str, that will be plus equals to ch dot lower. All right. Okay, and then we can just, after this one, return the new str double equals to, how we can reverse a string in Python. We can do something like this: new str square brackets colon colon. Okay, not this one. All right, -1. So in that way we can reverse a string. All right, so this is our naive approach. So here the time complexity, that will be big O of n square. Okay, because we are basically recreating the string for each of these iterations. Okay, so that is why the time complexity is big O of n square. So what exactly is the space complexity? So space complexity, that will be big O of n. We are creating a new string here. All right, run this one. Okay, all right, as you can see, we are passing all of the test cases here. Awesome. Now let's see our two-pointer approach. So first of all, what we will do, we will create this one. So the left, that will be at 0. The right, that will be the length of the string, basically -1. So that will be at the end of the string. Okay, the end character. Now before moving forward, so let's do not use the is_lnum function which is inbuilt to Python. Okay, so let's create our own. So how we can do that? So let's create, so is alpha numeric. So here we will get self at the first argument because it is inside of the class, and the second argument we will have the character here. Okay, and here we can return if the order, okay, let me just do something like this. If the order of the character, okay, so it should be alphanumeric, right? So the order, basically the ASCII number, should belong to inside of the range of the lowercase a to z, the uppercase a to z, or the 0 to 9. So what we can do something like this. So ord of capital A, if that is inside of this one, okay, ord less than or equals to of z, okay, and then, or once again I will just copy paste this one. Okay, it is not copy pasting, so I will just copy this one and paste it down here. So that can be from a, small a to z as well. Okay, or that can be from 0 to 9. Okay, so if that is the case, so basically the ASCII value of the character, if it lies between the capital A ASCII value to the capital Z ASCII value, or it lies between the small a ASCII value to the small z ASCII value, or it lies between the 0 to the 9 ASCII value, then it will return true. Okay, so in that way we can check if the character is alphanumeric or not. So now let's do something like this. Okay, so we will add a while loop, while left less than right. Okay, all right, and inside of that we will check while the left is less than right. Okay, and not self dot is alphanumeric. Okay, self dot is alphanumeric of the s at the left index. Okay, if that is the case, then left basically plus equals to 1, and we will check the same thing for the right one as well. Okay, so if I just do something like this, so if the right is greater than left and the character at the right index is not alphanumeric, then right, so I'll just do right minus equals to 1. Okay, so we are just moving our pointers here. Okay, and then we will check if s at the left dot lower, okay, is not equals to s at the right dot lower. So we are lowercasing the characters and it is not equals. That means it is not palindrome, right? Okay, then return false. All right. And after doing all of these, then what we can do after doing this one, so we can do something like this. So let's do the left. So we have to update our pointer in case of a perfect match, right? So left plus equals to 1 and right minus equals to 1. And then we can just, after this while loop, return true. Okay. All right. So this is our code here. Okay. So this is our solution. So we have coded our is alphanumeric function here as well. Okay. And why we are using self? Because it is inside of a class basically. Okay, in case if you do not know about object-oriented programming in Python, I have a dedicated Python course on YouTube here. Okay, please check that out. All right, so now what exactly is the time complexity? The time complexity will be big O of n because we are just basically going through the string only once. And what exactly is the space complexity? That will be 1 because we are not allocating any sort of space here. So run the program here. Okay, as you can see, all of the cases are passed. So submit the program. Okay. All right. Okay. And once again, do not worry about this one. So I am having a LeetCode to GitHub sync plugin. Okay. So that is why I am having this button here, and that basically messes around with my the runtime here. Okay. So don't worry about that, but it is quite optimized here. Okay. All right. So this is how we can solve the is palindrome problem on LeetCode.